So welcome to all for the Discovery webinar. So initially I'll be starting with giving some differences between the older version and the newer version of Ansys Discovery. So for each and every version, there are a lot of enhancements which is developing by the Ansys team. So is to simulate the problem which we are giving into the system. And in refined mode, we are having a lot of controls in the system since it is working in a CPU based solver. So the solvers which are using in the flagship software is also same. So at that time, it will take some additional time to complete the process, which will lead to give us the high fidelity and the high quality simulation, high quality results. So when compare the result accuracy between the explore mode and the refine mode, in the explore mode, which will give the very less accuracy values when compared to the refine mode, since we are having a very less control on the machine side. So which will completely tied up with the GPU solver, the results which you are getting in real time. And smart model prep. So basically we are having a number of tools for clean up the geometry or modified the geometry, but in the newer version, so whatever the welded components which is being involved in the simulation, so those things will be taken care by the newly added features. And the third thing is design exploration. So OptiSlang is the software which is help us to optimize the model as well as the simulation results. So the OptiSlang has been added recently to the Ansys Discovery. Earlier, we don't have this software inside this Ansys Discovery. So why the Ansys OptiSlang helps in a way to find out the n number of iterated values at a single time, and it will give us which combination of geometries as well as the physics conditions is the good results. So that is why OptiSlang, which will help us to identify what combination of input conditions or the design iterations is the best results. And these are some of the physics enhancements as well as the model preparation enhancements and the usability improvements which is taken, which is considered to developed in this 2024 version. One is live GX enhancements. In the earlier stages, it would have taken almost 10 minutes to 15 minutes to solve the basic problem, but nowadays it will take maximum 30 seconds to 1 minute to solve the basic problem. From the earlier version to the newer version, almost 10 times time has been reduced to solve the simulation. And the second thing is polymesh has been introduced in 2 or 3 versions before, but now the robustness of that meshing has been improved a lot. And the third thing is generate mesh before solution. So in explore mode, what happens is without meshing, we'll be able to get the results because the automation which is being run behind the solver. And in refined mode, we are having a lot of controls in the meshing. So you will have to do the meshing until and unless you are not having any design changes. But in explore mode, if you're change your physics conditions as well as the design changes, which will give the live results in a real time. That is one advantage in explore mode. Auto local sizing in electromagnetics. Whenever we are dealing with electromagnetic simulation, so anyway we are dealing with smaller components in electronic simulation. So at that time the element size should be very much smaller when compared to the remaining simulations. So it will be taking care, the system will be taking care by automatically. And some of the radiation enhancements has been taken care by this Ansys Discovery. In earlier stages, we will be having only body to body radiation transfer, but now we will be having a surface to surface radiation transfer as well. So there are the 2024 R version has been developed in a way to give some robust results or the high fidelity results in the basic simulations like laminar and turbulent flows. So when come to the FEA, the stress results has been improved because in explore mode itself, we will be having a resolution and the local fidelity option. So by using those two options, we'll be able to improve the stress results in the basic simulation of FEA. And earlier we don't have the frictionless contact, so they have been included this frictionless contact in physics solvers. So some these are all usually we are using in the earlier versions as well, but there are some enhancements which is taken by that Ansys Discovery team. And in the model preparation team, as we discussed in the previous slides, the weldment technology has been improved in the model stage itself, and check geometry enhancements. So usually we'll be having a number of features to find out what are all the simplifications that we need to take and what are all the errors which is present in the geometry. But we are having a check geometry option which will help us to find out each and every error in a single click. So that is where this check geometry feature will be helpful for us. So these are usability improvements, and they have added some additional features, some operational messages, which will be displaying near to the simulation information display. So you are not required to find out what are all the errors and what are all the information which is giving the simulation. You just click on that info tab. You will be able to find out what are all the errors and the information which is given by the simulation. So engineering notebook, they have added this engineering notebook recently. So in engineering notebook, you'll be able to write the notes, whatever you're understanding in the simulation stage or in the modeling stage. You can take the screenshots and you can you add into it, and you can share it to you can store it in some PDF or PPT format, and you can share it to your fellow peers. So this is what and all we have been discussed throughout the time. And I'll be moving to the modeling stage. So initially I'll be explaining about how to launch the discovery. Then I'll start explaining about how to import and export the geometry and what are all the formats the Ansys Discovery will support. And we'll be seeing those information initially. Then we will start working on one of the model to see real-time results. So in Windows itself, you will have to type Discovery, whichever the version which you have. You can directly, since it is a standalone software, you can directly open through your Windows, or else if you are having a workbench access, you can open it through your workbench file as well. So this is how we'll be able to open the model initially. Once you open the software, you can browse your files, and you can double click or you can drag and drop the model into your Ansys Discovery interface. So these are two ways that we can open the model. So the second, once you start the Ansys Discovery, this is how initially the welcome screen will be appear. So here they'll be give you some guidelines how to handle the software, and what all the features are available, and how to if you're not feasible with some of the options, you can alternate your options by using settings option. So this is the slide. If you're not able to see the welcome screen while starting the Ansys Discover app, so you can click on the home page in the file menu. So the welcome screen will be appear here. So once you see here, these are there are three options available in the home page. One is new, and one is browse, and one is learn. New option. Once you click on the new option, you'll be able to. It will directly take you through the stored folders inside the system, and you can open the model which is required for your simulation. Otherwise, if you want to create a new geometry inside the discovery, just click on the new and start creating a new model. Uh, Based upon your dimensions which you have. And the second thing is click on browse and search for the saved files which has already been stored in the system, and drag and drop that model and start working on the simulation. And the third thing is learn. Once you so I'm just explaining what are all the things, what all the items are presented in this learn option. Once I start showcasing everything in the software. So this is the setting. Once you click on the file menu, the settings option will be available. If you're not satisfied with the user interface, you can go and change based upon your interest or the requirements. So if you want to change the units and dimensions, you can go to the click. You can go and click the unit and display operation, and you can change the dimensions as per your requirement. So if you want to, we have two user interface themes. One is dark and one is light. So this is dark, this is light. So based upon your convenient and perception, you can change the user interface themes. So we'll be having a three stages. One is model stage, which will help us to create the geometry as well as clean up the geometry. Second one is explore stage, where live physics solver which help us to give the real-time results. And the third stage is refine stage, where we are having a lot of controls to refine the mesh and get the high fidelity and quality results at the end. So while launching the software, if you want to open the interface in the model stage, you can set it over here using the general option. So default stage, as of now, I set it for model. If you are having a simplified model, then you can change it to the refine or the explore stage, which will directly take you through that particular stage, and you can start working on the simulation. So these are some of the default units. If you want to change the units based upon your current project or the future projects, you can set it up the dimensions which is required for you. And the third thing is you can set your decimals up to how many numbers which you want. Usually we are dealing with the simulation for up to 2 decimals. So I set it for 2 decimals, and the degrees for 1 decimal, which is more than enough to get the capture all the high fidelity results at the end. So I'll till now, what are all the features which is available we have seen, and from now I'll be explaining about the user interface. So once you start importing the model, you'll be able to see the namings of the model, which we called as a model tree. And once we start applying the physical conditions to that model, the physics tool will be up, physics tree will be appear here. So this is where which will help you to understand what are all the physics conditions that we have been applied to the system. So whatever the physics conditions which you apply to the system, which will be appear here. So if you want to so this is heads up display, which will help you to access the mostly common user tools for the modeling, as well as the physics, as well as the selections. And the third thing is saved scenes. Once you complete the simulation, based upon your interest, you can save the scenes in 3D as well as 2D. And this is where you can create your namings, or we have a power selection tool where which will help us to create which will help us to segregate same area phases to apply the physical conditions. If you are having a inlets at a different locations with the similar areas, if it is difficult to find out, you can use the power selector tool to find out the same area phases and start giving the inlet conditions, or whatever the conditions which is required to that particular phases. And this is a viewer usually helps us to change the orientation, or gives us the proper perspection of the model. So this is the stage selector. Initially we'll be starting with the model, and once you click on this right arrow, that will take us to the explore stage. And once you click the right arrow mark again, and it will take us to the refine stage. So this is the ribbon where we can access n number of tools. Initially, we will be having a design there. Uh, what are all the features or the tools which we expected or required to design the model? So all the tools will be appear here. So the second one is the display. If you want to change the color of the face or color of the body and everything, you can change it using the display option. The third one is measure tab, where which will help us to find out the area or the volumetric surface, or volumetric area. I mean surface area or the volumetric conditions. You can find out the values for that by using this measure tool. And the repair option, which will help us more in cleaning up the geometry. So if there is some extra edges, or there are some holes while creating the fluid volume, to close those things and to identify those things, the repair tab will help us to clean up the geometry. Repair tab, which will help us to create internal flow, or the external flow, or the enclosure. So those kind of things, prepare tab, which will help us. So to create the conformal meshes, we'll be having a shade topology option, so which will be available under the prepare tab. So these are some of the basic tools which we usually deals with. One is the fill tool. So wherever the unwanted curvatures and unwanted holes are there, you can use this option to fill those gaps. So by using this model tree tab, you'll be able to change the color of the bodies as well as the faces. So whatever the namings you have given, you just right click, you just click on this square, and you can change the color of that particular domain, which will be helpful to find out uh, in a better way in the later stage. So this is the heads up display. This is how usually once we select the faces, heads up display will works, and we click on the hexa, it will take us to the halo, and there we'll be having a modeling tool, commonly used modeling tools, as well as the selection tools, as well as the physics tools, which will be available. So uh, this is the basic interface which HUDs will show up. If you want to change the spaces between uh, this HUD, then you can change it in the settings. If you see here, heads up display size, this is the comfortable position which interface recommends us. This is the compact. This is the compact way to see the heads up display, and this is the wider visualization of this heads up display. So this is the physics tree where we can apply the materials as well as the physical conditions. So while using them while creating the material, if you see in the material tab, if the diamond logo tells us that uh, these are all the materials which will be available if you are having only the granta license. If you are seeing the discovery logo in the material side, so you can directly take that material for this particular simulation. Or else we can create our user defined solids as well as the fluids, and we can store it for your future simulations as well. So if you are having any doubts at any stage, you can click on the F1, which will take us to the overlay help, where whatever the features or the tools which is displaying in the user interface, everything will be explained by this overlay help. So once you click on the F1, the overlay help will open, and you can see about each and every tool which is present in the interface, and you can go through that and you can understand about that particular tool and the feature, and you can execute and you can work on it. So this is one of the advanced feature which we have. So in the flagship models, these features may not be applicable. You just need to open the help section and you can go you can go into the help section and you'll have to read the entire thing. But here, by the arrow marks, they will be explaining you everything, and you can directly apply those features to the model. And some of the physical conditions, they will be giving some videos as well to understand in a better way. So that's all for the explanation, sir. I'll take them to the live demo. Is that
Yes, yes.
okay? Is that okay, or do I need to add anything apart from?
No, no, no. You complete it. I'll tell you later.
Sure. So this is how the user interface of Ansys Discovery. If you're not able to see the welcome page, you can go to the file menu and click on home page. The welcome screen will be appear here. So once you click on these tabs, you'll be able to see new, browse, and learn. So these are the three options which we were discussing earlier. So to create the new geometry, click on new, and if you have already created geometry, click on browse and deploy the geometry into the interface. And if you want to learn some of the things, if you're not feasible, if you're not convenient about Ansys Discovery, you can use these items to learn more about Ansys Discovery. This is actually the welcome screen, where you can change how the user interface should be look like before moving on to the to the discovery and working on it. So this is where the getting started tab will open. So they'll be explaining clearly what all the stages will be available, how to handle the user interface, how to change the setting. So those are all some of the basic introduction that they have been given in getting started. So what are all the ribbons available, and what are all the stages available, and what are all these indicates to us. So if you want to if you're not convenient on the Ansys Discovery recommended operations, you can change your controlling settings as well. So this is how getting started tab will be appear. So if you come to the what's new tab, so the recent version water and all, they have been enhanced, and water and all that they have added when compared to the earlier stages. So as we discussed in 2024 R1 version, these are all the enhancements and the added features which is available for us. So if you come to this section, you'll be able to see the recent files or the sample files. If you're not convenient and you're in a learning stage, you can use the sample section to they have already set up the simulation as well as the modeling, and you can view those things, and you can see how the simulation has been set up and how the modeling process has been taken up. These are the interactive tools for the part design as well as the model preparation and the beams and shells and the static structural. So since we are having a number of simulations, so for each and everything we are having some tutorials for that. So we can use this, and we can familiarize ourselves with the tool. So this is how usually the interface looks like. Since I am having the model geometry, I am trying to input the geometry into the Ansys Discovery interface. So this is how initially geometry looks. We'll start with this. So this is the basic model geometry which we have. So since this is a valve, we are trying to see how the fluid is flowing throughout the domain. So since we are having a two inlet, so we'll be seeing how the two different fluids with a different temperature is going to mix it together, and uh, how the end propagation of that fluid will be. So that is how our objective here. So so since we are dealing with the fluid, initially we will have to extract the fluid volume. So as we already explored, we will have to go to the prepare tab, and we will have to click on the volume extraction tool, which will help us to create the fluid volume. So we have a two ways to extract the fluid volume. One is selecting by the edges, and one is selecting by the faces. While selecting the edges, you can directly go and select the edges and extract the fluid volume. While selecting the faces, we will have to select the seed face as well. Seed phase, in the sense, you just select one of the phase where the fluid is going to interact, so that it will automatically identify throughout the domain, throughout the fluid domain. So I'm selecting the phases of the both inlets as well as the outlet, and I'm selecting the seed phase, one of the phase where the fluid is flowing. And if you want to preview the inside phases where and all fluid is flowing, you can click on this preview inside phases option. You can scroll down and scroll up. You'll be able to see from where to where the fluid is flowing. So since the fluid volume is flowing from two inlets to one outlet, so which is showing the proper way the extraction of the fluid volume. So once I confirmed with the fluid region, I just click on the green color tick mark, so that the fluid region has been created. Since we are only dealing with the fluid, we are not dealing anything here with the solid. So I am just hiding that solid. So I'm not applying any conditions to the solid as well. So I'm just suppressing by clicking this green color mark, which will turn it to the red. So that means the part which we have surplused will not be part of the uh, simulation. So once you start once you extracted the fluid volume, you just need the second thing is you will have to give the material properties for that fluid. Since this is a fluid, I am giving R as a fluid. If you see here, the diamond logo, which indicates us if you don't have the granta license, which will not allow us to take these material properties inside the discovery. Since the discovery logo is available, we can directly take these material properties to the current model. So I'm clicking, so I'm selecting water for this particular demo. So these are all the properties which you are taking. If your density or the temperature where the fluid is flowing or the working, you can change based upon your requirement just by editing the values here. So if you want to create your own material, you can do that as well. Just by typing user defined solids, since it is a fluid, I'm creating a fluid material properties for this. So once you enter this, you can click on the drop down menu and you can enter your material properties over here, and you can save it for your later simulation stages as well. I've selected up the fluid properties, and the second thing that we need to provide the boundary conditions to the system. So this is the inlet, first inlet phase, and this is the second inlet phase. This is the outlet phase. So I'm just giving the boundary conditions to this. Just by clicking the phase, heads up display will be appear here. You can click on this heads up hexa, and it will bring us to the halo. Since we are giving only the fluid to the system, I'm just enabling this fluid. Yeah, I have selected the phase, and I'm considering this as a velocity inlet. So I'm clicking the inlet here. So which will once you click on the uh, green color tick mark, it will take the inlet condition. And this is the inlet 2. And we are taking this outlet as a pressure outlet. So we'll have to change the boundary type here to outlet, and you'll have to give the pressure outlet. If you see here, so what are all the variable that you need to select at the inlet as well as the outlet, you can change based upon your input condition. If the inlet is velocity, then you can click on the velocity. If your inlet is if your inlet value is in mass flow rate, then you can click on this mass flow rate and start giving the value for that. So initially, for the first inlet, I'm considering 1 meter per second, and for the second inlet, I'm considering it 5 meter per second. So since we are in explore mode, we are not required to bother about more on meshing, since since the solution has been tied up with the GPU. So based upon the GPU capability in the system, we will get the results very fast. So two things that we need to take care, since it is an automation process to give the speed results, two things that we need to take care of in the meshing stage. One is the resolution. So you just need to increase the resolution by using this logo under the system information display. So once you started looking less number of red color marks, that will tell us that the model is high resolution system, or the geometrical properties has been captured in a proper way. So if you're reducing this tab, so you'll be start seeing that more number of red colors, which will tells us that geometrical properties has not been captured in a proper way. That's the reason we are increasing the resolution for this up to max. So the second thing is size preview. So you can see what is the maximum discretization, what is the minimum discretization that we are doing for the entire modeling. So so we don't have any option for that. Once you click on this entire model, the global fidelity approach will be enabled. So here what we need to do is you just need to go with the advanced version by just selecting a custom. So it will automatically discretize the model as per the solver or the automation process based upon the simulation. So, and one more thing, the inlet conditions which we are giving right now is only fluid. That's the reason the inside the simulation information display is showing only the fluid logo. Once you start giving the temperature, once you start adding this temperature values to that fluid, the logo will the logo will convert to the temperature as well. Once you start clicking this temperature logo, it will enable the option to give the temperature for that particular field as well. So for the first flow inlet, I'm considering the ambient temperature for the fluid, and for the second inlet, I'm considering 50 degrees Celsius for the fluid. If you see inside the system simulation information display, the fluid flow logo has been added the temperature contours itself. So that indicates that the conditions which we are giving involves both the fluid as well as the temperature. So once you're done with applying conditions and increasing the fidelity and the resolution of the geometry, you can start running. This is the result arc where we can start running the simulation, and we can see the animations of that, and we can see the results in different ways. So you can change steady state to the transient state as well, just by selecting the feature options which is available near to the SID. Since I have applied every condition, you just
Please
need to
hold
click
on, Lokesh.
yes, sir.
Okay, I'll move for the different meeting now. Okay,
Okay,
let's
yeah,
give a comment now. Okay,
yes,
so it's basically you started at 12:38. At
yes,
12:38 to 1 o'clock, 20 minutes, you gave a discovery quick guide.
yes.
Okay, after that, you started a software